Right, okay, so here I'm trying to explain to you a bit of GCSE physics special related to current and electricity, the electricity module. Here there are a few questions especially for practicing a bit of the usage of equations and also to understand what's really going on. Okay, so that's one of these questions here, and there are actually six questions, little questions A to E, which is related to that diagram. Okay, so you can try this question if you want before I'm going to answer these things anytime, and you can just check the answers with me or whatever. Right, so let's see what they're talking about. So they say, name the components X, Y, and Z and explain their usage. So X is here, that's Y, that's Z. So they want us to basically name them. We can see if you look into that, here it's X. There's a component given by A, like A. There's a round and A. So you should recognize this as an ammeter. It's an ammeter. The ammeter is to measure the current. So the A would be, X would be ammeter. What it does is measures the current. Measures electric current. Current within a circuit. Within an electric circuit. Normally you can just write measures electric current, that's fine, but I just written for completion measures electric current within a circuit, actually a circuit loop, but that's fine. So why now? So the symbol you should recognize, this is nothing but the resistor, you see? So you should know the symbol, this sort of a symbol you should know straight away. That's resistor, okay? That's why it's a resistor. It's a resistor. Now, what a resistor does, what it does actually is, generally speaking, is reduce the current. Is reduce the current flow. Simply speaking, it reduces the current flow because it's a resistor. It's actually an electrical resistance, isn't it? There are many types of resistance. We have mechanical resistance, electrical resistance, heat resistance, so many resistance. But here there's an electrical resistor which is reduce the current flow. Reduces the current flow. Or flow of current or current flow, or whatever way you like it. The other one is Z. If you look into this component here, is connected parallelly and also given as V. This component basically voltmeter. You should be able to recognize it, voltmeter. And keep in your mind, voltmeters are always connected parallelly. They never connected series like that. The ammeters are always connected series. Okay, ammeters are always connected series. Whereas the voltmeter is always connected parallelly. Okay, so that's basically voltmeter. What it does is basically measures potential difference across a component, or simply speaking, it measures potential difference. Like here, for an example, it will measure potential difference here across this resistor. There's another resistor here across that resistor. Okay, measures the potential difference. Or you can take voltage, but is a better word or better term, potential difference. It's much more accurate, if you will. Potential difference across a component. Or just simply you can say measure the potential difference. That's probably sufficient in many cases. Okay, so that's basically, so the question A is fine. So let's look into question B. Okay. The total resistance of the circuit. So the total resistance they're asking. The total resistance, we can see there are two resistors serially connected. Series circuit, as a series circuit. So there are two resistors here. One is this, another one is like that. They're connected series. The series connection. So it's 10 ohms and 5 ohms. Now we can easily find the total resistance. Pretty simple, we can add them together in a series circuit. The total would be then, we can replace it 15 ohms. So if you want, we can say we can replace a one resistor with 15 ohms. That will do the job of having two resistors like that. That's the reason we are replacing something, you see. Because this does, it does the job basically having two resistors like this. So equal thing. Or you can have it 15 ohms, or you can just have two resistors. Okay? So that's it. C. So that's basically, let's go to C. Calculate the readings of X and Y. X and Y. To find the readings here, the readings of X means they're asking basically the current. Because why? Remember, X is an ammeter, it's measuring the current. So the readings of X should be, they're asking basically for the current. So let's look into that. So to find current here, there are a few equations we have learned. In this case, the best equation probably we can apply V equals IR. The Ohm's law basically, V equals IR. Because we know the voltage is 300 volts. Voltage is given for the whole loop. We can apply V equals IR for a loop, for this loop. V is 300 volts. And I is the one we are looking at, and R is the resistance here. In this case, the total resistance should be considered. Total resistance is 15 ohms. We found it before. So V is 300, and I is basically I we don't know, and R is 15. So we can divide 300 by 15. We're going to get 20 amps. It's quite high value, but it's okay for a question. 20 amps. Okay. So that's basically C. Sorry, that's readings of X. That's a reading of X. Okay. Now they want us to find the reading of Y as well. Now reading of, I would say not reading of Y, I think this is a mistaken. Reading of Z. This should be reading of Z. That. Reading of Z, because reading is a voltmeter, isn't it? Voltmeter reading, they're asking. So, how do you do that? So to find again voltage or the potential difference, but again we can use V equals IR. Now V equals IR can be applied, before we applied for the whole circuit, now we can apply for this, across this terminal, across this 5 ohms resistor. Okay, you can apply V equals IR here, right? That's quite important. Keep in your mind, you can apply V equals IR as a whole loop, like a loop, this is a loop, or we can apply across a component. So we can apply if you want here or here. But in this case, they're asking the readings here, Z, so we can apply V equals IR to this point. So when you do that, we require, we are looking at V, so we require I and R. And R we know it is 5 ohms, and I, we know, we found I before as 20 amps. So we can easily find that. The reading of that would be, let me do it here. But we can apply V equals IR to this, V equals IR across 5 ohms resistor. We can apply V equals IR across the 5 ohms resistor. So V is the one we are looking at. I is 20 amps, because that's 20 amps now. We found that before. 20 times 5. 5 is the resistor, so 100 volts. So that reading is 100 volts. Okay, I think this makes sense. So the first three questions basically we did, ABC questions basically we have used, the first question was all about just, getting to know the components. Second and third questions were about applying because IR. Okay? So let's go to the other ones then. Let me get rid of these one. Okay. Question E. Actually, there is a little error in A, B, C. This should be D. That should be E. That is F. Okay. Anyway, question D. They say the power generated by the batteries. The power generated by the batteries. The power generated by the batteries. That battery. We know the power equation P equals VI. And volt V is the voltage across the battery, it's 300. And I is the 20 amps. 20. So we got then 6,000 watts or joules per second, the same thing. 6,000 watts generated by the battery. Okay? And E, the amount of work done by the battery during 5 minutes. So amount of work done by the battery during 5 minutes. The work done and time equation E equals PD. E means energy transferred, E equals power times time. That's the energy transferred or work done, the same thing. Work done and energy transfers are the same thing. That's work done. Work done. Or we can say energy transferred. Energy transferred. Same thing. P is the power. We work that out over 6,000 on the battery. And time is in second always. So let's do that. Let's do this. 6,000 times T is 5 minutes, which means 5 times 60. Cool. So we're going to get here 36 and 4 zeros and times by 5. Any questions? No. So we got 180. That amount of joules being transferred. You can use the calculator anytime. Okay, I hope that makes sense. Because always we have to convert this one into minutes, because they say 5 minutes. For each minute is 60 seconds. Times by 5 give you 300 seconds. Okay. All right. So that's basically it. The last question is F. Let me gather up this bit. The amount of power dissipated through the component Y. The amount of power dissipated through the component Y. Again, power dissipation and power generated, the same equations can be used basically. Same equations. So if you want to find the amount of power dissipated through that, we can use P equals VI if you want. Again, P equals VI. The voltage across this. So how do you find the voltage across this? Now before, in a previous question, we found the voltage across this was 100, isn't it? It was the 100 volts was the voltage. Then this should be 200 because one, there's a series circuit. 100 plus 200 gives us 300. Okay, so the voltage across Y, that should be 200, and I is 20 because it's the one loop, so times by 20. Okay, so it is power generated 4,000 watts. Power generated is watts. It's power generated watts. That's work done is joules. Okay, so I think it makes sense. Also, if you want as an extra question, we can do an extra question. We can say, let's say for an example, the amount of charge, I'm writing it this now, pass through, amount of charge passed through the circuit during 5 minutes. The amount of charge passed through circuit, where it doesn't matter where, just the same amount of charge passed through circuit during 5 minutes. So how do you do that? So they're asking the amount of charge passed through the circuit during 5 minutes. So what sort of equation we can use for that? Well, even though when I'm saying equations, they are not just to memorize, but to understand what they mean as well. The physics is not all about memorizing. It's quite the opposite. The relationship we can use, or the equation we can use here, probably you might be thinking like Q equals IT. These are definitions of, this is a definition of current basically. Q is the amount of charge. Q. I is the current, we know it's 20 amperes. Time is again 5 minutes. So 5 times 60. 300 basically. So 300 seconds times 20. 6,000 coulombs. That's it. In coulombs, keep in your mind. Coulombs. It's G. Okay. If you want, we can just add another question. Let me add another little question for this. For example, somebody might ask us the amount of which is related to that amount of question like this. For example, amount of electrons in this 6,000 joule, 6,000 coulombs. The amount of electrons in it. I think other day we discussed a similar question in the class. So the amount of electrons in there. To do that, in order to do that, we require the charge of an electron. Let's say the charge of an electron is given. Charge of an electron, you don't have to remember any of these values. Charge of an electron, let's assume it's given like this. 1.6 times 10 to the minus 19 coulombs. Okay? Minus 19, let me just get on this line. Minus 19 coulombs. Now somebody's going to ask us, all right then, how many of them are there? So what are you going to do? We can divide 6,000 by that. It's pretty simple, isn't it? 6,000 by that, get the number of electrons. So number of electrons equals charge over charge of an electron, which is E. Let's say normally in physics, charge of an electron actually given as E, actually. If If you want, you can keep this as an equation. Obviously, you don't have it, but if you want, you can write like Q divided by E. So we got that is 6,000. 6,000 divided by 1.6 times 10 minus 19. If you want, you can write this one as 6 times 10 to the 23 divided by 1.6, because that is 6 times 10 to the 4, and we can write 10 to the 19 when it's come to the top, divided by 1.6. Okay, so add them together, indexes, they're a bit of mathematics. Well, you can use a calculator anytime. Calculator is allowed, because I don't have a calculator right now, so I'm just using my head. So this is almost like 4, isn't it? Almost 4, because if it's 1.5 will be 4, less than 4. Let's say it's 4 for the time being. So as an average, you can say the answer is around 4 times 10 to the 23 of electrons. Huge amount. This amount of electrons are in 6,000 coulombs. Okay, this is an additional question. It's not really, I don't think it's very important, but why not? Just probably can just give it a go. Cool. All right, mate. So I think this bit of helpful. So I think it's enough for today. All right.